Hello AFTA students. I'm going to do a sample of the final project so you'll be able to do the same steps in your final project. I'm going to start by choosing a data set, and I'm going to choose a data set that was not in your choices so that you don't have to eliminate any of your choices. So the data set that I chose is days since March 14th and number of confirmed coronavirus cases in the United States. So I'm going to start my project by titling it Study of the Number of Coronavirus Cases in the US. Final project by, and you're going to put your name here. Okay, on the next slide, this is where you're going to put the data. So you can take a picture of your data. So you could use Snagit. I can't use Snagit right now because I'm using Snagit to record, but you can use Snagit. You can get a picture of the data, and then you're going to put it back into your project here. Okay, so once you paste your data in, you do want to also add a few sentences about why you chose this data, and you can create a text box and just type it right in. And then you want a link to your data as well, and there should be a link along with the spreadsheet that you choose. So I'm going to go back here. There's my link. And copy it. Oh, I think I need to copy it from here. And I'm going to put it up here. But I don't want that one in orange. I think I just want it to be a regular blue link. So let me change the size. And I'll change the color. Okay. All right, so once you have your data, you are going to put this data into Desmos. So I'm going to open Desmos and click Start Graphing. You want to sign in. So right now I'm signed in, but if you are not signed in, you click Sign In, and you're going to sign in with Google and choose your school email account. Okay, and then you want to paste the data over here. So I'm going to go over here and I'm going to copy the two columns, and then I'm going to paste it over here. Okay, and they zoomed to fit my data, which was really nice. I'm going to give this a name, so I'll call it graph coronavirus cases. And I'll hit save, and now I'll have it for all of the regressions that I need to do. So going back to my project, I need to do a linear regression. So remember that a linear equation is y equals mx plus b. So to get the regression, first I'm going to add a new f of x expression, and if you look at this table, this is titled x1 and this is titled y1. So we want to use those terms in our equation. So instead of y equals, it's y1. And then to show that we're doing a regression, we use this tilde, which is in the top left of your keyboard. And then we're going to do, you can do a or m, it doesn't matter, m x1 plus b. All right, so my equation is going to use this number for m and this number for b. And this is the graph I have right here. So the first thing I'm going to do is get the graph. So I'm going to click Share Graph and Export Image. You can use it with a thin line. I like the thicker line. Download it. And then I open it. And then the three dots that are in the top right, I click on that. And I can copy it. Okay, So now I'm going back to my project, and for the linear regression, I'm going to paste it. So this is just the graph. I need the equation as well. So I'm going to type in the equation. Y equals mx plus b, but now I need to replace m and b with those numbers. Okay, and just as a reminder, I got my numbers for m and b from the regression that I performed in Desmos. So you can see here's the m and here's the b for this line right here. Now I have to go back and talk about whether this is the best fit for my model. So I really don't feel like this straight line is capturing the curve of the data here. So I'm going to type, I did not choose this model because it does not match the shape of the data. Alright, so next I'm going to try the quadratic regression. So the quadratic equation is y equals ax squared plus bx plus c. And again, we are going to use y1 and x1 when we refer to these two columns. So I have y1 and then the tilde and a x1 and then squared. So to get the squared you need to go down to the keypad and hit squared, then plus b x1 and plus c. Okay. So this model seems to match pretty well the shape of the data. However, the left side is kind of weird. So this means before March 14th that the cases would have been higher and they would have gone down, which we know didn't happen. So I'm a little skeptical of this model, even though it does fit the points real well. I'm going to get this picture into my slideshow, and I'm going to use these numbers here for A and B and C. So let's get the picture. You need to share your graph and export the image. You can keep it on thin, you can change it and download it, open, and then copy. So I'll put the picture here and size it. Okay, so my equation is going to be in the form y equals ax squared plus bx plus c, but I need to go back and find my numbers for a, b, and c, and I need to type those in here. Okay, so now I have the A, B, and C that I found in my quadratic regression. I'm not sure yet if I want to choose this graph. I want to see the last one first, and then I'll come back and decide if this is going to be my best fit or if it's going to be the exponential regression. Alright, so the exponential regression, I just want to remind you of the parent first here. So the form is going to be y equals A times b, and that's going to be raised to the x minus c plus d. Okay, so just a few reminders about the transformations here. The b is the base. The c is going to shift the curve left and right, the d is going to shift the curve up and down, and the a is a stretch for the curve. So we're going to be using this in Desmos now. So I'm going to get rid of this one, and let's substitute in the other one. So I have a times, delete all of that, b raised to the x minus c plus D. And I forgot the 1 on the X, that's why I don't see anything. Okay, so here are my numbers for A, B, C, and D. So I need to substitute those numbers for A, B, C, and D, and then get my equation into my project right here. Okay, so now I have my equation. I'm going to go back and get the graph. So click Share, Export, and Download. Open it, and copy it. Okay, so there's my picture. So now I need to decide whether this looks better or this looks better. They both seem to fit the points really well. However, this one, the left side, makes a little bit more sense than this one, where for some reason there would have been a decline in the number of coronavirus cases before it started going up. So because this left side doesn't make so much sense, I am going to go with the exponential regression. So I'm going to choose this one because it matches my points the best. Okay, and after you choose your model, you're going to need to find the practical domain, practical range, and then the intervals of increasing, decreasing, or constant. So for the practical domain, I know that I could start with 0 coronavirus cases. However, at 0 coronavirus cases, right here, I'm at negative something. So what is this here? Oh, this is day 0. So when X is day 0, you would have negative coronavirus cases, so that's not making so much sense. So I'm trying to choose the day where I cross. I'm going to have to zoom in a little bit. Right here. Okay, so it looks like I start with 0 coronavirus cases 1.2 days after March 13th. So I'm going to go back and use that number. So my domain starts 1.2 days after. And then I need to figure out when it ends. Now, it's really hard to know. I don't believe that this exponential model will go on forever. We've seen lots of pictures about cases actually going back down again and then coming back up again. So, but I do need to follow this model here. So what I decided was it would have to end when everybody in the United States has had the coronavirus, and our population is about 331 million right now. So that's going to be the top of the range. So the range would be from 0 to 331 million. But what I need to know now is, what would the X value be? How many days would it take for 331 million people to get the coronavirus according to this model, which we said may not actually continue all the way up. So what I did was I took this model here and I added the equation y equals 331 million. And I can't see that line because 331 million is not on my y-axis here. So I just kept zooming out until I could see it. Oops, other way. So you can see it's getting harder and harder to see my original curve as I zoom out. 331 should be times 10 to the 8th. Okay, so there's my line there. So let me see if I can click on the intersection if it will tell me. It does. So 331 million is this number here, 3.31 times 10 to the 8th. And this tells me it would be about 64.5 days before everybody in the United States has the coronavirus. So obviously we know that's not going to happen with social distancing and all the precautions that we are taking, but I'm just following my model. So 64.5 days would be the end of my X's here. So I'm going to put that here, 64.5 days. Now, I didn't put increasing, decreasing, and constant because looking at my graph, as I read it from left to right, I can see that the entire graph is increasing. When you list increasing intervals, you always use parentheses. And you start at your first X value and you end at your last X value of increasing. Since the entire graph is increasing, the numbers I'm going to use are the exact same numbers as my domain. Okay. All right, so I am going to use this model to make some predictions. So I'm going to start by recapping what I know about my model. X is the number of days since March 14th. Y is the total number of coronavirus cases in the United States. And this is the equation of the exponential regression that I chose for my model. All right, so the first thing I'm going to do is I'm going to see what's going to happen a few weeks after March 14th, and I'm going to use that to kind of test whether or not my model is accurate. So I chose the day April 4th, which is 21 days after March 14th. And so I took that 21 for my X and I substituted it in the equation for X. And then I put this all in the calculator, not the Y equals. I put all of this in the calculator and I got my answer. Okay, so I took this number of cases for April 4th, I went back to my original website that the data came from, and I compared it, and I found that it wasn't completely accurate. So my analysis of this prediction is the answer is larger than the actual number of cases on April 4th, which was really 277,965. All right, for my second prediction, I need to choose a Y value. So I thought it would be interesting to know when the number of cases would reach 1 million. So this would be when the Y is equal to 1 million. So I went back to my graph, and instead of finding when the Y was 331 million, I just want to know when is the Y 1 million. All right, and actually I'm going to zoom out a little bit so I can see better, or zoom in, sorry, so I can see that red line a little bit better. Okay, so you can see the curve a little bit now. So I'm looking for where the curve crosses 1 million right here. And that looks like it's 27.8 days. Okay, now so because I'm supposed to show my work here for prediction 2 and I use the graph, what I'm going to do is I'm going to take a screenshot of this piece of the graph so I can show how I found that. Okay, so this graph shows how I found my answer for prediction 2, and now I'm going to move on and do analysis of the predictions. So when you do analysis of the predictions, you need to answer these two questions with several full sentences. Why were these important questions? And what are the implications of your predictions? Meaning, what does it mean, your predictions? What does that mean for you and me? All right, so I'm going to put in what I typed. So I asked the first question because I wanted to see how accurate the model was, and I asked the second question because I felt people would start to take the risk more seriously when the number of cases reaches 1 million. What are the implications of your predictions? Well, my first answer was off by over 50,000 cases, so that did make me think my model is not extremely accurate. And I could have made it more accurate by adding more points to my table of values. The second answer tells me that it's not too long I have to wait before we get to 1 million cases, and I hope people will then start to follow advice about staying home and washing hands. So I'm going to end this video, and we're going to continue the project on a second video.